Hello everyone, welcome to another video again. This is a fresh video from Jamro's Electronic Solutions. Today we are looking at a Honda Accord. Okay, we are looking at the Honda, and this Honda is a non-start. The problem, the owner has left it not being used for some time, and that's what has caused it not to start. So I just want to try and confirm the complaint first. I'm inside the car, and let's see. Yeah. I'm inside the car. Is my key. So I'll put it on the clutch. You can see there's nothing on the screen. I'm sorry, it's a little bit dark. Yeah, maybe if we do this way. Let's do it this way. I've got my key on the start position, and there's nothing on the dash. You see that? Not even a single light. You can check, the whole thing is dead. All right. So that's the ignition key. Let me show you what I'm doing here. So I'm turning the ignition key onto the start position. You can see that I've turned it onto the start position. Look at on the dash. There's nothing. No light is on. Nothing is happening. Okay. So let's go and investigate the battery and see what is going on. So I want to test the battery and see what the battery is like. So I'm going to show you how you connect the meter. So this red lead, it goes onto this jack here. Okay, it says voltage, resistance, capacitance, and frequency. The black one goes onto the common jack. Okay, we are testing, remember, we are testing voltage. We are not testing current. If we were to test current, we would take that one and put it in here or there, depending on the size of the current that we're dealing with. But in this case, we are dealing with voltage. So I'm going to turn my meter to direct voltage, as you can see here, because we are dealing with direct voltage in the battery. And then I've got my black lead to the negative and the red lead to the positive. And look, the voltage that I'm getting, 0.0545. okay, let me show you something while I'm here. What will happen if you swap these leads? Let me swap them around. Okay, I've swapped them. Look what we are getting now. We are now getting a minus 0.0. Whenever you see a minus in front of a number when you're checking voltage, then you know you have swapped your leads. It will do no harm to you don't need to change them around, because you're going to get the same figure. Only the difference will be that it doesn't have a minus. So in this case, we have got a zero voltage. Okay, this is 0.0545. okay, what do we do with this? So I'll try and jump start this battery, okay, or maybe charge it a little bit. I'll charge it first, see if it still takes charge. If it doesn't, then I'll have either to get another battery and connect another battery. Okay, go. Right, let me take you back to something that I had not told you. Yesterday when I went to recover this vehicle, I thought, well, let me jump start it, because it was stuck in the middle of nowhere, and I thought, let me jump start it, once it starts, and then we should be able to drive it to the house. And this is what happened. I don't want to duplicate it here in case there is a fire. The next thing that happened, it melted the positive lead. I saw smoke coming out, and then straight away you can see it just, I think you can see the evidence. This is plastic that is melted. Okay, and this happened yesterday. That's when I realized that something is not right. So I pulled out quickly whenever I saw the smoke. I just pulled the jumper leads, took them off, and the next thing I thought, okay, let me get another battery and replace this one. Okay, let me do that and show you what happens. So I'm going to remove this battery. Surely we notice that it's not showing any voltage. I'll check the open circuit voltage. Okay, this is what you see what I mean by open circuit voltage, right? So now it's not connected to anything. Let me put the meter again and confirm my open circuit voltage. Look at my open circuit voltage. I've got roughly 5 volts. Okay, I've taken off the leads. There you go. I've got 5 volts in there, and so that's what we mean by open circuit voltage. The battery is not connected to anything. So I'll lift this battery out. I have a good battery here. I have a good battery, and let's connect a good battery. Maybe we check the open circuit voltage first for a good battery. That's our open circuit voltage, 3.6, fully charged. Okay, a fully charged battery, gentlemen, if you're asked that question, fully charged battery is 12.6. all right, a fully charged cell is 2.1 volt. all right, that's for our lead acid battery. So that's if we have a fully charged battery, and we do the connections, and let's see, connect the negative. Look what is happening. Do you see that? I'm going to remove the negative before I cause a fire. Did you see that? I've disconnected my negative. There's smoke coming straight from the alternator. Okay, let's diagnose it together. I just want us to demonstrate this. Sorry, I wanted to demonstrate this to you. Let's diagnose this problem together. So I was checking earlier on, and I looked at right now that let me show you something here. Move the battery terminal on the alternator. Let me take it off. Let me take the battery terminal off. It's a 12 socket. Okay. Let me see if yeah. That's it. Disconnected. So if I disconnect that part, even if I come to the battery now, connect the battery, let's see what happens. See if we have smoke. So we don't have any smoke. Okay, we don't have any smoke, as you can see. Right, so I will try and crank the engine and see. The assistant will stay here in the front and see if the engine is gonna start. So you can see that the engine runs, no smoke, nothing, there's no issue. So there's an issue between the positive terminal and the same post on the back of the alternator. something is shorted here, and I would want to investigate that. I want to believe it's internals of the alternator. I want to believe the problem is inside the alternator. I don't think it's that cable. It's not touching anything, because I can follow it here and see it's shorter. Just comes from there, runs at the bottom. That's it here. That's it, you know, out here. So I don't see where it's touching anything, but I want to believe that the short is inside the alternator. That's where we have our problem. So the engine is running sweet, as you can see, but the battery light is on. I'll confirm that the battery light is on. So you watch here, you'll see a battery here. There is a battery symbol that is coming on. It's not charging. There is another one. You can see there's another one again. It's showing it, you know, double here. So the alternator is not charging. It is not connected. There's no power going to it, as you can see. So that's where we are. Our issue is in the alternator. So I will take that alternator apart. But before I do that, maybe I need to go to the wiring diagram and see what is connected to what inside that alternator. So I just want to do something here. I've never done this in any of my videos, so possibly this will benefit somebody. Definitely there's a short to ground. That's why you see that you saw the smoke coming out of the alternator. So what I want to do, I want to check if this cable, remember that's the one that comes to the back of the alternator. I have disconnected it here, as you can see. It's disconnected to the back of the alternator. It is disconnected onto the battery. So here's what I'm going to do. I will connect my ground. Okay, I will connect my ground, and then I will take this probe and go to the ground, and then touch. So what I've done, I've selected resistance on the scale here. All right, so I want to see, I'm testing a short to ground. Take note of this. This is a short to ground. So I'm going to touch this positive. Do you see that? Let me do it again. If I touch that positive, look at that. It shows that there is a short to ground. Okay, look at that. If there was no short to ground, it would just be OL. There is a short to ground. That's confirmation that there is short to ground. So here's what we're going to do now. The next thing is, which one of these is shorted to ground? Okay, so I want to isolate. If you can check, we have these other wires that are coming in here. We've got that one there. So I want to see if I can just test this big wire that goes to the alternator. That's what I want to ascertain and see which way can I do that. Maybe let me isolate this one. Isolate one of these. Yeah. Let me isolate one. I can't isolate that one, but I might follow it and see where it's coming from, because I want to see what is this, what is causing this short to ground. You know, it must be attached somewhere, as you saw the smoke belching up. So let me do it again. I've disconnected that one. Fortunately, I can't disconnect the other one. I'll do it again. So if I go to the negative, and then look at that. Yes, we do have a short to ground. And now I'll go to the back of the alternator and touch. Look at that. You see that oil? Keep an eye there. When I touch this wire, do you see that? We do have a short to ground. So this short is actually outside the alternator, as opposed to what I said. It is actually outside the alternator. So I was wrong when I said the short is inside. I thought about it later and say, hey, let me just check this wire for a short to ground. So now we've confirmed the short to ground. Please guys, this is important now. I wasn't testing an open circuit here. I'm testing a short to ground. Disconnected both sides. Touch your ground. Or maybe you might say I'm touching the battery. Okay, let me just find somewhere where there's good ground. Let me go on the... Let me find... I'm just trying to find good ground. You see? Look, I'm on the battery, on the shock bolt there. See that? Look on that. Look what my meter is reading. Okay, let me maybe do it while it's watching. OL. Touch. Look at that. So we do have a short to ground, and now it's gonna be an interesting one. Where is it? It's on the positive terminal, but there are so many wires, as you can see. There is, let me show you here. You see, this one here is the one that goes to the alternator, that white one. But look at the top. There's this wire that is coming. Possibly it's this one. Let me follow it and see. Maybe if I can eliminate it on that side, that'll be good. Here is a mistake that I made when I was checking for a short to ground. I forgot to disconnect the starter motor. I only disconnected it. I forgot it's the same cable, so I need to take it off the starter motor as well. I apologize for that. That was wrong diagnosis. So now it's off the starter motor, off the alternator, of the battery. Let's do the same test again. My apologies. My apologies. So we go, and then we go touch that, and then we go and touch our positive. Yeah. Still communication. Right, I have disconnected quite a number of cables. It's all right, they're okay. There's no polarity when you're checking this. So I've disconnected that one. It comes here. This is the one that you see on top there, right? So that's the only cable that is connected, to our terminal. So if I watch this, so if I go in there, hang on here. Yeah, right. Do you see what I've just done here? Go back. I just want to show them. See, when I put my finger there, it's now reading continuity in me. Let me show you. If I take off my finger, that goes to OL. Okay. There is no issue at all. Okay, if I go here, there is no continuity, so there's no short. Okay, I made a mistake of putting my fingers here like that. Show them on the other side, and then it started reading, so I thought there was still a short. Okay, but no, there's no short. Guys, learn from these mistakes. I'm showing them so that you can. I don't want you to repeat them. Okay, don't want you to repeat these mistakes. Don't put your fingers there. It's now reading resistance. It's using me, sorry, for continuity. It's using my body for continuity. So do not. Okay, so I can safely confirm now that there is no continuity, so which means that this cable is not shorted. The short was because the continuity was there because this cable here was connected there and somehow it was backfeeding to ground. So once I disconnected it, now we do not have any relationship between the ground and the positive terminal, which I'm relieved, because this diagnosis now can help me to conclusively say the problem is the alternator. That's where we started, but I had made a few mistakes in my diagnosis, but here I can conclusively say there is no short to ground on these positive terminal wires. So our issue is in the alternator. So what I'm going to do next, I'm going to remove this alternator, take it off. Let me take this plug and see how many wires do we have here. Yeah, we have 3 wires. Okay, we have a blue and a white and blue, and then we have a white and green, and then we have a black. Is it black and cream or black and yellow? Okay, white and green, white and blue, then black and yellow. I would like to go on the wiring diagram some stage to see what each wire is doing, but at the moment I'm satisfied that my problem is the alternator. I'm going to take it out. Right, ladies and gentlemen, we are back with a new alternator. From our diagnosis yesterday, we removed the old alternator, citing that it had a short inside. If I can just recap quickly, we ended up disconnecting these cables, these wires, so that we could ascertain whether the short was in the wires. So we carried out a test for short to ground on these wires, but we determined at the end that there was no short. But at first I thought there was a short because this one was connected. See, this wire was connected here, and somehow it was finding a path to ground. And once I disconnected that, I made another mistake again. Remember, I was testing it with my finger like that, and it was reading, a continuity through me. So I'm gonna leave those mistakes there so that we can also learn from those mistakes. I know I can polish this video, I can take the mistakes out and say, right, this was perfect, and then you think, ah, great, this guy is great. But we also make mistakes, guys. I'll leave them there. If you want to learn from them, it's up to you what you think, but I'm leaving them there for your learning. So here is the new alternator, and I'm going to put it in. A bit fiddly. It is a bit fiddly, but you know what? It's doable. It is. So it goes in there. Okay, those are the 2 lower bolts at the bottom. Yeah, 2 lower bolts at the bottom and then 1 at the top here. Okay, so it is a little bit fiddle, but we'll get there. We will get there. So that's not too bad. Not too bad. So I'll get the bolts. I've fitted the new starter motor. It's in place. I didn't feel like I needed to show you this. It's just 4 bolts, 2 at the bottom and these two at the top, and then the belt, of course. Yeah, it's a bit fiddly here, but it's doable, you know. If you can, what I did, I actually used a flat spanner. It's a ratchet spanner, and then, you know, I did something silly, you know yourself. This is what I ended up doing, because I don't have the long spanners. I've been looking to order new long spanners. I'm gonna do that because I don't want to be, you know, widening my spanners like that. These are my assets. So now, if we've done a wrong diagnosis, we are going to see smoke again. If our diagnosis is good, we are not going to see smoke. So this is a moment of truth. I've connected the positive. Remember, when you disconnect the battery, you start with the negative and then end up with the positive. But when you are connecting the battery, you start with the positive and end up with the negative. The reason being, if I'm tightening the negative and I touch the body, there's not going to be a spark, because this negative is connected to the body anyway. So that's why we connect the positive first and the negative last. But we disconnect the negative first, the positive last. Get that pattern, you'll not go wrong. So here we go. Now I'm gonna connect. That's me connecting. Let's watch for smoke on the other side. You know, by now this smoke will be coming out, but we don't have smoke at the moment. Just tightening this side while the cameraman is showing you the alternator. Okay, so we have no smoke. So the next thing then that we're going to do is to go to the dashboard and see if we've got lights. Remember, when we started this video, we didn't have any lights on the dash. So come here. You can see the key. I've just put the ignition key in there. There you go. We've got dashboard lights. We didn't have. So, does it crank? Can it start? Battery light is out. The engine is running. So we'll go to the front and check for any smoke. I guess you can see the engine is running, and I'm not smelling anything, and I don't see any smoke coming out of the alternator. You wouldn't do that with the old one. You would have seen smoke even with just the battery connected. Without the ignition key on, smoke started coming out. Remember what it did to my jumper lid? It just melted the jumper lid. I had to fix it again. So here's another job that has been done right. A way I want you to put emphasis on this video is, how do you determine that the fault is inside the alternator? We had a short to ground. We could see this is a short to ground, and I checked the cable to make sure that it wasn't in the cable from the battery to the alternator, and there wasn't. We concluded that there was no short to ground, and then we say then let's replace the alternator, which was a good decision. You might look at this as a small thing. This alternator is 200 pounds. Imagine asking the customer to buy an alternator for 200 pounds, and then you realize, oh no, the short is not in the alternator, it's somewhere else. You put a new one and then you see smoke belching out. You don't want to see that. I hope and trust that you'll enjoy this video. You'll enjoy these few tricks. I told you, I'm going to leave all the mistakes that I did for your learning, for my learning, for everyone who is going to watch this. And it's easy for me to remove them, gentlemen, but I want to see that, I want you to see that I do make mistakes. They say that a man who is not working is the only person who doesn't make mistakes. Once you start working, you are bound to make mistakes. So thank you very much. This is Diagnose Electronic Solutions. Please consider to subscribe. We thank those who are subscribing. Thank you very much. And look, I could have done more tests. You know, I can connect the scope and do other things, but it's just that it's raining over here. You know, anytime it can start raining, so it's cloudy, as you can see. And maybe, you know, look at the skies. You know, you might think this sky is lying, but there you go. It is. You can see those thick, dark clouds. So I'm not going to be able to do anymore, but I'm happy that battery light is out. Alternator is working fine. Here's the other thing that I didn't say to you. I connected a new battery for one reason. I bought a new battery for one reason. Usually when you see an alternator do what it was doing, you may find that the battery has now high resistance. When the battery develops a high resistance, gentlemen, you are not going to see that with a multimeter. You are going to see that with an oscilloscope. If it develops high resistance, it causes the alternator to work harder. And as the alternator is working harder, the diode starts to overheat. Now you have a problem. So I didn't want to risk a 200-pound alternator for a battery that just costs 100 pounds. So I replaced it straight away. And because you saw the old battery was 1 volt, it was less than a volt actually, it was 0.0 something. So I didn't want to risk a new alternator, end up frying the diode. I've seen it before. I've seen that before. So if you have any questions on battery high resistance, if you don't understand that, because I know many people don't get it, let me know. I will explain further to you. I will give examples as well. Thank you very much. Hope you are going to enjoy this video. Please consider to subscribe and also post any questions and give us your likes. Thank you.